Hello guys, today I'm going to present on elastic and inelastic collision. The first picture here is elastic collision and the picture down here is an inelastic collision. In an elastic collision, both bodies move separate after the collision. In an inelastic collision, both bodies move as one after the collision. Important keywords that we need to know is collision. When two or more bodies collide, it's when the bodies exert forces on each other for a short period of time. Kinetic energy is the energy an object has while it is in motion. It is the work needed to accelerate a body from rest to its stated velocity. The formula is half mv squared, as you can see here, mv squared over 2. Momentum is the product of mass and velocity, which can be written as P equals mv, which stands for momentum equals to mass times velocity. 3 letters down here I'm going to use in my presentation. M stands for mass, U stands for initial velocity, and V stands for final velocity. Elastic collision. In an elastic collision, the momentum is always conserved. The total kinetic energy is also always conserved. And after the collision, both the bodies which collides returns to the original state and moves separately after the collision. As you can see in the image here, two balls runs into each other. They hit each other, and after the collision, they move away from each other. Two scenarios. First one is body 1 and body 2 with mass m1 and m2. Body 1 has a velocity of v, body 2 is at rest. So after they collide, body 1 stays at rest and body 2 has a velocity of v because they change their velocity. And the momentum is conserved in the system, as you can see. Mass 1 times initial velocity plus mass 2 times its initial velocity equals to mass 1 times the final velocity plus mass 2 multiplied by the final velocity. For kinetic energy, C, half mu squared of body 1 added to half mv squared of body 2 equals to half mv squared of body 1 after the collision, half mv squared body 2 after the collision. Same goes for the second image here. After they collide, they both move apart to their original state, move separately. Momentum is conserved, so is the kinetic energy. So type 1 of an elastic collision is the mass of two bodies are equal. So body 1 has a velocity of v1 and body 2 has a velocity of v2, which is 0, meaning it's at rest. When body 1 collides with body 2, they exchange velocity, so body 1 will stay at rest and body 2 will have a velocity of v1, as you can see in the image here. An example would be when I play pool with my friends. I hit the ball 1, and before collision, ball 1 is in motion, ball 2 is at rest. But after collision, ball 1 stays at rest and ball 2 is in motion, because they change velocities. Type 2 of an elastic collision. In this case, body 1 has a greater mass than body 2. So body 1 has a velocity of v1 and body 2 has a velocity of v2, which is 0, meaning it's at rest. When body 1 collides with body 2, body 1 still has a velocity of v1, but body 2 will have a velocity of 2v1. An example is when my friend plays golf. I notice him. He uses his putter, which is the golf bat, the mass of m1, and velocity of v1 to hit the golf ball with a mass of m2, and its velocity is v2, which is at rest. So if the speed of the golf putter is 100 miles per hour, meaning that after collision, the velocity of the golf ball will be 200 miles per hour. Type 3 of an elastic collision. So in this case, body 2 now has a greater mass than body 1, as you can see here. Body 1 has a velocity of v1, and body 2 has a velocity of v2, which is 0 meter per second, meaning it's at rest. So when body 1 collides with body 2, which has a much greater mass than it has, body 1 will have a velocity of negative v1. And body 2 will still remain at rest because the initial mass was v2. So a perfect example here would be, I'd like to use a tennis ball, but yeah, it's a baseball here. You throw a ball onto a wall and it bounces back to you. That shows that if you throw the ball, it has a velocity of v1, it collides with the wall, and the wall has a lot of greater mass than it has, so the ball bounces back with a negative velocity. In an elastic collision, so when the total kinetic energy is not conserved, the momentum is always conserved. In inelastic collision, the kinetic energy is not conserved. Two objects stick together after colliding, so the total momentum before and after collision stays the same because two bodies become one. Yes. So something that we should know is the momentum is always conserved. Even if it's an elastic or inelastic collision, yes, the momentum is conserved. But in an inelastic collision, total kinetic energy is not conserved. It's really important. The two objects collide and they stick together and become one. So here's an example of kinetic energy. Super Saiyan 3. If you watch Dragon Ball, it's Vegeta, yes. Super Saiyan 3 has a kinetic energy, which is a lot. And during collision, it loses its kinetic energy and goes to the Super Saiyan 2. This is more kinetic energy and goes to Super Saiyan. And at last, it goes back to its normal state. It shows the loss in kinetic energy after collision. That's why I chose to put this image in here. An example of an inelastic collision is a sport we all love to play in America, American football. So when an American football player collides with another American football player, they move together as one, as you can see in the picture here. So how do we find the mass of an inelastic collision? It's really easy to find. You have the formula of momentum, m1u1 plus m2 to m1 plus m2 in brackets v. So we can find both the mass and the velocity here. So the example here is showing that two cars are moving the initial velocity of u1 and u2 to each other, and they have a mass of m1 and m2. These cars stick together after the collision and moves with a velocity of v. We know that the total momentum before the collision is equal to the total momentum after the collision. So we can solve for the velocity after collision with the formula of momentum. So putting in the numbers, m1 u1 plus m2 u2 equals to m1 plus m2 in brackets v. Mass 1 was 10 kilograms. Velocity, initial velocity of body 1 was 5 meters per second. Body 2 is 5 kilograms. And it's at rest, as we saw just now. So we know that it has equals to after collision. So equals to m1 plus m2 means 10 plus 5 v. We get 50 plus 0 equals to 15 v. So we can solve for that. V equals to 50 over 15, which is 3.23 meters per second. So it isn't hard to calculate the momentum at all. And in an inelastic collision, kinetic energy is lost. That's the stuff here. Thank you for watching my presentation. I hope you enjoyed it. Thank you.